Doing some IR spectroscopy on soy sauce. Let's see what we get. Yes, collect a new background. Right, let's see if we get something. This machine's having a bit of trouble, and I don't know what to do because I'm not like experienced. Well, I know how to click scan basically. 1 bad scan, 2 bad scan, 3 bad scan, 4 bad scan, 5. Oh wait, the soy sauce is on there. We're getting a lot of bad scans. This isn't good. We're just scanning the background spectrum so that we can subtract this from our sample spectrum. Okay, good. We got our background. Now don't click scan yet. No, that's previous scan. Stuff. Right. So now we're going to add the sample to the crystal. So we've got some soy sauce here. So we're doing IR on soy sauce. We don't need to put the crusher on it because it's a liquid. It covers the crystal. You only need the crusher for solids.
Turn it over.
What do you want?
How else are you gonna do the scan?
Mate,
Eugene.
you don't need this if it's a liquid. It doesn't matter where it is here.
It does.
Because the infrared gets refracted through the crystal and back into the machine anyway. So having that above it doesn't do anything. It literally doesn't do anything. Anyway. Right, let's click scan.
I already did.
Nice.
Well, that was the background.
Oh, that's the background.
Was that the background? No, that's the...
Click scan again.
Oops.
Yeah, as you can tell, I don't know how to use this machine.
So do I.
Right, there we go. We got our IR spectrum for soy sauce. So because it's a mixture of stuff, we don't get like super sharp peaks for specific bond stretches. It's just a mix of lots of bond stretches. So I'm not surprised by this, that we just got a giant fat fingerprint region, which is just a huge sum of lots of stretches. We might want to have a look in this peak. This peak is interesting because it is reasonably sharp.
I think it's about CH or CC stretch or something.
It's not going to be CH
Bend.
stretch.
Bend.
CH stretches. Oh, CH bend maybe, yeah. And then here we've just got our hydroxyl peak because it's a solution in water basically.
And a bunch of hydrogen bonds.
Yeah.
In this peak.
So it's there we go. That's soy sauce.
Okay, cool.
Right, so we're doing our spectroscopy in courgette here. I've got some courgette that's kind of dried out. It's still a bit wet on the inside, but anyway, I've got a chunk from it here. We're going to do IR on this. We're definitely going to get a hydroxyl peak. There's still a lot of water in here. So we just put it on the crystal, but because it's a solid this time, instead of just sticking it on top, we're going to have to crush it down.
Don't crush it too hard.
Crush it very hard. Lovely. That's good. And then click scan on this disgustingly greasy mouth. I bet it's covered in lots of dangerous organic products. Force gauge, lovely. It's in the green region. That's probably a good thing. And let's see what we get for courgette. We got the same as soy sauce.
It's going to be pretty much the same because you just have like lots of carbon bonds and OH.
I wonder how its intensity compares to soy sauce.
Oh,
It'll overlay the spectra once it's done.
you know what? We're about to find out. Whoops. Ah.
Oh wait, has it not finished scanning yet? Is it still scanning?
Oh wait, what?
Click scan once more, and it should complete it. Usually you have to click scan twice. I don't know why. There we go. Now it's actually doing the scan. Right, so there's our courgette spectrum. We're doing IR on courgette. And as you can see, it's almost identical to soy sauce.
Yes.
Right, we've done some important science here and concluded that courgette is roughly the same as soy sauce. As you can see, it's just a slight difference in peak height here and here, which is the entire reason they taste different, and that's it. I think I should just clarify that both these peaks here and here
are due to water in both our samples, since neither of our samples are dry and contain a lot of water. So this peak on the left is due to oxygen-hydrogen bond stretching, and this peak on the right is due to oxygen-hydrogen bond bending. This one particularly is very broad because water exhibits hydrogen bonding, and this can in turn affect the bond strength between oxygen and hydrogen. And the water, not every water molecule is constantly exhibiting hydrogen bonding, which is why you get a broad peak, because there's a range of bond strengths due to not every molecule exhibiting hydrogen bonding. I think this would be a much more interesting experiment if the samples were dried, so that we wouldn't have the IR spectrum of water drowning everything out. We do have a bit of a difference here, which I guess does show that we had two different samples with slightly different chemical compositions, but obviously these differences are insignificant compared to the amount of water. This height of this peak here is due to the courgette, and I think it may be higher just because the courgette is drier than the soy sauce, because it's not literally a liquid mixture. So this peak might just be higher because there's less water relatively.